In this video, we're going to see minterms and maxterms in digital circuit design or logic design. Minterms and maxterms form a very basic fundamental stepping stone in analyzing and understanding digital functions. First, we will discuss minterms and then maxterms, and we will consider some canonical SOPs and POS terms. We will see them, what they are, and we will discuss them in detail in the next video, these canonical SOPs and POS. So to start with, let us take minterms. If we have n variables, then how do we say or form a minterm? The way we form is, we can define minterm as, minterm is a product term which contains each of the n variables in either complemented or uncomplemented form. That is called minterm. Let me write down the statement for reference. To understand it, let us take here n is 3. Okay, so we're going to consider 3 variables and see how a minterm is formed. Okay, so let me take variables x, y, and z. Now as we have 3 variables and each one can take two possible values, 0 and 0 or 1, so we have 3 variables, 2 times 2 times 2, which is 8. So we'll have 8 combinations. Let me write down here the 8 combinations, 0 0 0, and let me write down the rest. Now each combination is going to be represented with one minterm. Okay, so let me take a column known as minterms. Okay, so now for the first combination, how do we form a minterm by using that? So the rules are, if we have a variable here, in this case x, and if the value of x is 0, then we represent that in terms of a complemented variable. So we write it as x bar, okay, and it's a product term, so for y it's dot y bar, okay, dot z bar, which is all in complemented form and in product. Okay, so if you write for the second one, it is x bar, y bar, z. Okay, for the third, x bar, y, z bar. Okay, third one, x bar, y, z. Fourth one, x, y bar, z bar. X, y bar, z, x, y, z bar, and x, y, z. So what is the basic behind writing it like this? Is there any use? So let us see, take this one, the first one. Okay, let me write down here x bar, y bar, z bar. Okay, so if you have this term, if you see, if you substitute any combination from here, suppose say this one 0 1 1, if you substitute x as 0, we'll have 1 times, as it is complemented, right? So if you have y is 1, so y complement is 0, and z is 1, z complement is 0, right? So we'll have 0 as the resultant. And if you observe, for all the combinations, this particular term here, okay, will have output as, or its resultant value as 1 only for this particular combination. And for the rest of the combinations, if you give, the resultant value will be 0. Okay, that is a basic fundamental thing we need to understand from this minterms. So you'll have only one resultant 1. So you'll have minimum number of ones for a particular term. So it is a minterm. Okay. Now if you can consider any other term, it'll give a resultant 1 only for that particular combination which it represents. Okay, so this is how minterms are represented. We have taken 3 variable combination here, we can go further. Okay, so now as we have discussed minterm, let us see maxterms. Okay, maxterms. So just like we have given a statement for minterms, so let us give a statement for maxterms too. Okay, so a maxterm is a sum term. Okay, here in minterm it was a product term, so for maxterm it's a sum term which contains each of the n variables in either complemented or uncomplemented form. Okay, so let me write down the statement here for you. Now how do we write max term for each possible combination we are having for these three variables? So for the first one, we're going to have, unlike minterms, this is reverse kind of, okay? So if you have 0, you're going to represent the variable as it is. But to have a distinction, what I'm going to do is we will be taking capital letters for these variables. So I'll take x, I write it exactly, okay, the same variable x. If it is 0, okay, plus, okay, it was dot in minterms, here it's plus. So x plus y plus z, okay. So in the second case it is x plus y, let me take capitals, and z bar, okay. And the third one, x plus y bar plus z. Fourth, x plus y bar plus z bar, x bar plus y plus z. In this case, x bar plus y plus z bar, x bar plus y bar plus z, x bar plus y bar plus z bar, okay. These are the combinations. So you can see the corresponding minterms and maxterms for a particular combination of input. Just like what we have seen for minterms, let us see what a maxterm will give us as an output, okay. Suppose take the first combination, okay. Let us take x plus y plus z. Suppose this is a maxterm, and now this maxterm's output will be, okay, 0 only for the input combination 0 0 0, and for any other combination other than this 3 being 0, okay, any other combination, the output will be 1. If you go on seeing it, you'll have 1. So it means for this particular term, max term, okay, for whatever combination it is corresponding to, it will have a 0 as its resultant value. If not, it will have 1. So it will have maximum number of 1s as output, right? So we can call it max term. But the way usually people remember is, okay, but this sounds funny, but as if you look at the term, the way it is represented, right? So it looks smaller and it looks bigger, right? So max term and min term, okay. Now getting back, so we know the basic difference between this min terms and max terms, but why are we defining it like that? Okay, how are we going to use it? Fine. Suppose for that, to make a better understanding, let us take a function, okay. So I'm going to take a function, okay, which has, whose output will be 1 for input combinations. Suppose say, let me write down decimal values for this, okay. This is 0 1 2 3 4 5 6 7, okay, to just make life easy, okay. So this function output will be 1 if input combinations are odd, okay. But let me take 1, okay, for 1, for 3, for 5, and 5 7, and for the rest of the things it's going to be 0, okay. So we need to represent this function. So we can represent this function in terms of minterms and in terms of maxterms also. So if I want to represent this in terms of minterms, I can write down saying that, okay, sum of, okay, x bar, y bar, z plus, because that particular corresponding term, plus the next one is x bar, y, z plus x, y bar, z plus x, y, z, okay, fine. This is written in terms of minterms, and this is also known as canonical sum of products, okay. The function is supposed to be 1 for these particular terms, so those particular terms we have picked here, okay, not this, sorry, this, and this. So we are writing it as a sum, because if this function will be 1 if at least one of the input combination is given as input for this function. So that's why we'll have 1, right? So this is how we represent. Suppose we want to represent this function in terms of zeros also, right? So we are saying that the function should be 1 when this input combination should be 1, 3, 5, 7. And we can also say that if the input combination is 0, 2, 4, and 6, the output should be 0, right? This is another way of saying the same thing. Okay, so how do we write that? Okay, we can write it like this. Okay, in terms of max terms. Okay, so x plus y plus z, for whichever input combination the function is going to be 0, those are the things which we are going to write. But in product term, okay, so x plus y bar plus z, okay, times x bar plus y plus z times, okay, x bar plus y bar plus z, right? So now this is the way of representing. And why did we take a product of it? Because at any point of time, if any of these terms or combinations are given as input for this function, the output should be 0. Okay, because if at least one of the combination is given as input for the function, that function will be 0. So 0 times anything is 0, so it will make sure the function is 0. So that's why we take product. So similar reasoning can be applied for this sum of products. Okay, so let me write down here and let me rub this off. This way of representing is known as canonical, okay, sum of products. Okay, canonical is synonymous to standard way of representing, okay, the sum of products. We are taking sum, okay, you can see the sum symbols here, these are logical sum, okay, sum of product terms. These are product terms, right? So we are taking sum of product terms, and it is called canonical because we are using standard way of representing by using minterms. Okay, so similarly this we can call it as canonical product of sums. Okay, in short form people usually call it as SOP. Okay, and this one POS. Fine, we will see in more detail how we represent these functions in terms of a short form representation and so on in the next coming video. Okay, if you like the video, please do subscribe, and thanks for watching.